Hello, Professor, and welcome to our Programming Project presentation.
Our project objective is to create a command-based interface to support core CIUD operations with data validation, error handling, as well as unique enhancement features. The file organization for our project is as such. The C files are mainly there to handle the main program loop, conduct the CIUD operations, as well as to pass and validate the user commands. The H files hold a whole host of global variables, constants, arrays, as well as structures that are used throughout the entire program.
Each student record is represented using a struct, as every record contains a fixed set of fields: ID, name, program, and mark. Using a struct keeps all these related pieces of information grouped together in a clean and organized way. All student structs are stored in a dynamic array and is allocated in an initial block of memory at the start of the program using malloc. It has a capacity limit of 100. If the number of students grows beyond the current limit, we use realloc to resize the array by doubling its capacity.
Here's how our CMS processes every command. First, the user enters a command, where this goes into our parsing and validation stage, where we detect the command keyword, extract any fields, and validates the syntax and values. Then in process command C, the command dispatcher takes over and routes the command into the correct function. Next, in student C, the execute stage runs the CRUD operation, interacting with the student array and struct, and updates memory. Finally, post-execution actions are performed, where backups are returned, unsaved changes are flagged, and the system returns success or error message.
The open command is used to load the database file into memory so that other operations can be performed. Firstly, it allocates initial memory for the student array. Next, it will open the database file and read each student record. It will skip any invalid records and only store the valid ones into memory. It will use realloc to automatically resize the array if the records exceed capacity. Finally, it will close the database file and mark the database as open. The help command is used to understand the correct syntax for all commands available. When the user enters the help command, it will open the help.me.txt file and prints out its contents directly onto the console.
The show all command is used to display every student records currently stored in the database. When the user enters show all, the system first checks that the database is open and checks for the command syntax. The program then checks for any extra tokens beyond show and all. Since show all also supports additional clauses, any leftover tokens that are not cleared will result in an invalid command message to the user. Before printing, the program scans all the students' records to determine the longest value for each field so the table columns can dynamically adjust. Each record is then printed in a formatted table. The insert feature in the CMS is made up of two main components: process insert command, which handles the parsing and validation of the user input, insert records that performs the insertion into the database. The general syntax of the command is as shown, with each field validated for correct format, length, and value range. First, process insert command performs all parsing and validation. It checks that the command begins with the keyword insert. It ensures the first required field is always ID. Next, the code then extracts and validates the student ID, enforcing numeric format, correct length, and checking for duplicates in the database. After the ID, the function moves on to the rest of the fields. In the parsing loop, the program detects and extracts name, program, and mark in any order. It also correctly determines where each value ends, allowing multi-word inputs like John Doe or computer science. All fields are validated, duplicates fields are rejected, and the function ensures that all four fields are present before proceeding. If the database array is full, a realloc call safely expands the student array so the system can continue adding new records without data lost. Once parsing and validation succeed, the program calls insert records, where this function double confirms when the ID belongs to an older batch of students. It then inserts the new record into the database, writes the update to the backup file, and prints the success message.
The purpose of the update function is to allow users to interact with our CMS system to change a specified field in a student record within the database. It only allows one field to be updated per command. The general syntax of using this command is as shown, with the student ID being the ID of the student to update, field for the attribute to update, and value for the value to update to. Updatable fields are name, program, and mark. Moving on to the implementation of the function. Once the function is called, it first ensures that the student ID of the record to update is valid, and then extracts the field and value while ensuring that only one field is being updated. The extracted field and value, the necessary validations are done on the values based off the field to update as shown. Once the field and value has been validated, a linear search is done to search for the record to update. If the student record is found, update the student's record field and value based on the command input and display a success message.
The query function enables users to search for a specific student's record through their unique 7-digit ID. It uses two main functions. Process query command handles the parsing and validation. Query records such as the database for the ID. After the user types in the query command, it will first check for valid syntax and then pass and extract the 7-digit ID string. Validation for extra characters and numerical range are also implemented. The program will then loop through the database to find the record and then output the result for the user.
Moving on to the delete operation, its purpose is to delete a record based on a specified student ID. So this is the main command flow. So first will be to check for a proper command syntax, that being delete followed by a space ID equals to a valid 7-digit student ID. We'll also be checking to make sure there is no additional trailing characters or white spaces behind the ID. Next is the main delete logic. So first will be to check that the ID inputted is a valid one. You'll then search for that record with that ID, prompt the user for confirmation of deletion before proceeding to the main delete. The main delete operation can be visualized as such. Let's say I want to delete a record at this index in the array. What I'll do is I'll overwrite that unwanted record with the one after it in the array. So I equals to I plus 1. And I'll keep doing this until the last record in the array. By this logic, there will be a duplicate of the last record in the array. So to remove this, I will simply decrease the count of the array to remove the last record.
The save function is responsible for writing all student records currently stored in memory back into the database file. First, the program checks whether the database has been opened. If not, the save operation is aborted. Once confirmed, the program opens the file in read and write mode. It then scans through the file, locating where the headers end and where the student records actually begin. After identifying the start point, the system removes the old records, ensuring all outdated information is cleared. Next, the updated records stored in the student's array is then written back into the file using the formatted output to maintain consistency. Finally, the file is closed, the backup file is removed, and the unsaved changes is reset to 0.
The exit command allows the user to close the program safely. On exit, the system first checks if there are any unsaved changes in the database. If there are unsaved changes, the program will warn the user that exiting will result in permanent deletion of the backup file and any unsaved changes. The user is then prompted to confirm exit. However, if the user cancels the exit, the program will return to the main loop. Else, it will begin to free the memory allocated to the student's array, remove the backup file, and terminate the program. The show summary command computes and displays key statistics of all the student records. It first validates that the database is open and checks the command syntax. It then calculates the total number of students, average marks, highest and lowest mark with the name of students who have achieved them. The results are then displayed in a clear formatted summary. The where clause allows users to filter records based on a single condition, either by pattern matching or direct comparison. We designed it to be loosely coupled so that the other compounds can easily reuse it. The general syntax for pattern matching is where field like value, and for direct comparisons is where field operator value. This feature works by first searching for the where clause in the command, and then extracting the field, operator or like keyword, and value. Additionally, it will apply the required validations on the values based on the extracted field. The values are validated accordingly if a like operator is used. After which, it will then filter the array for student records that fulfill the conditions stated in the where clause. The sort by clause lets users reorder records based on a chosen field and their preferred sort order. If no sort order has been specified, ascending will be set as the default. The general syntax is sort by field order. This feature first searches for the sort by clause and extracts the relevant values. After that, it validates the values to ensure the command is correct before proceeding. Once past validation, it will then use quicksort to sort the records based on the field value. The limit clause allows users to manage output size and focus on a subset of records. The general syntax of using this feature is limit value. When the command is passed into this feature, it will first search for the limit keyword. If it's not found, the original number of records will be returned as the limit. Else, it will extract and validate the value to be a positive non-zero integer. It will then compare the value against the original number of records, and the lower will be the limit value.
The update batch functionality allows users to modify the marks of multiple students with a single command. On the right-hand side, you can see the general syntax used for this feature. The system first takes the command and splits it up into individual tokens. This allows us to extract keywords such as set, where, and like. We then validate if the command matches our expected format. Next, we verify the validity of the mark expression. We only accept standardized expressions such as mark equals value, mark equals mark plus minus value. The program then checks whether the where clause exists. It also checks if the program field uses equals or like to match the student. A temporary list is then created containing all the students who meet the criteria. Once the list is prepared, the students' marks are then updated based on the value stated. All marks are restricted to the range of 0 to 100, and the results are rounded to 1 dp. Finally, the system sets the unsaved changes to 1 to remind users to perform a save before exiting.
The export feature enables users to export current database records to an external CSV or TXT file. The program will first check for the correct command syntax and then pass the file name from the command. The program will check if a file with the same name already exists in the same directory. If it does, it will prompt the user if they want to overwrite the existing file, ensuring file overwrite protection. It will then check for the file format before exporting accordingly. The import feature enables users to load student records from external CSV or TXT files to the database. After the user inputs the import command in the CMS, it will first validate the syntax and then pass the file name. It supports both quoted and unquoted file names in the command. Here, the various validation checks are used, such as checking if the file name is empty, valid TXT and CSV extensions only, and for special and extra characters. An appropriate error message is output according to the error detected. Next, a file type variable is then created to open the imported file. Memory is also pre-allocated so that it can accommodate large record size imports. The program will then process each line using a while loop and fgets. Next, a second round of validation checks are implemented. Finally, the records will be imported into the CMS.
Moving on to our demo, we will start by showing our main key features, starting with the help command, followed by the open command and then the show all command. We also have the show summary that sums up the records. Now we move on to the insert command. The insert command allows users to insert student records between years of 2014 to current year for older batches of SIT students. The program will prompt for confirmation before inserting. We also have other commands like update, query, and delete. Now, let's save the changes.
Seriously, auto-updating now? Microsoft!
Don't worry, our CMS has automatic backup and crash recovery concept implemented. Let's move on to the validation of the commands. First, we check on the leading space issue. Next, we check for buffer overflow risk. We then check for duplicate fields and formatting for insert statement. Then we check for missing fields and syntax. We also check for ID and numeric field validation. As well as typo commands. Let's move on to the enhanced and unique features, where we start by showing our enhanced show operation with where filtering of showing valid and invalid ways of using. Next, we have the sort by, then the limit.
We also have batch updates for marks showing valid and invalid ways of using the command. After that, we have the export feature. Next, our unique feature is to allow users to import data from CSV or TXT files. This saves time rather than doing many insert statements. Our import function validates all the fields to ensure the data is coming in is correct before allowing the student record to be added to the database. Our CMS can also be compiled and run on Linux environments as well. In conclusion, the CMS our group created successfully implements database operations in C with extra features like sorting, summary statistics, and import-export. project's modular architecture and comprehensive validation ensures reliability, scalability, and a great user experience. Thank you.